Hello and welcome back to CST 3130. So in this lecture I'm going to explain how you can extract data from spreadsheets. So start with a little introduction and then I'm going to give an example just based on football data from a spreadsheet, but this example is extremely generalizable to any other kind of spreadsheets you want to extract data from. So in this project you need some numerical and some text data. In the previous lecture, I explained how you can get this kind of data from web services, but web services sometimes have limitations on how many API calls you can make per day. They also have restrictions in terms of, sometimes they have restrictions on the free plan about how much historical data you can get, and more importantly, there's not always a web service that has the exact kind of data you want either. So if, for example, I had a student who did a project on kind of the top 10 over the last 50 years, like for music, kind of top 10, the pop charts kind of thing, and which kinds of music were in the pop charts over the last 50 years, and there is no web service you can get that data from. So in many cases, you can't get the exact kind of data you want to get from a web service, but you can get that data from a spreadsheet. So for this coursework, you're perfectly free to get the data from a spreadsheet instead of a web service, and that's why I'm doing this lecture on it. And a lot of people these days make data available online in spreadsheet format. And typically this has sort of got the aim of machine learning projects. So you might train up some kind of model to be able to make predictions about future genres of pop songs, for example, or future football matches. And there's quite a lot of repositories out there that hold this kind of data. So Kaggle's pretty good one, I think, and that's the one I use quite often, and my students use quite often. There's also, I had a quick look now, there's like the UCL machine learning repository, there's the Google dataset search, for example, and these datasets can be a great way to get a large amount of data without the limitations of free plans on web services. So this is Kaggle, for example, and there's the Google dataset search. And I just thought it'd be worth doing a quick demo to show how these things can work. So if you, for example, here's the Kaggle homepage. You have to sign up for an account to get the data, but it's not a big deal really. So if you're looking for, I don't know, I'll stick to the football data example, then you can select data sets, and you've got like over 1,000 data sets, on different teams, or transfer fee prediction data set. You can see whatever machine learning project you have, there's probably a data set out there on Kaggle or similar places that will let you do that project. They'll provide the data for training a model for that project. And similar here. Let's just let's try weather data just for a change. Here we got Kaggle, but we got whatever data RAID as long historical data for the last 45 years, and so on and so forth. So Google dataset search, pretty good. And just to understand how these things work, let's go back to the Kaggle example of the football data. So what's nice about these websites is they're very carefully kind of curated data sets. So you have, like, here we've got all the CSV files that we could download. We can either download individual files for each particular season, or we could download the final data set, which is what we'll be using for this example. What they also is nice is that they explain the meaning of each of the columns in the data. So we got here, I think this will be full-time something or other, full-time away goals, full-time home goals. It explains what's actually in the data set, whether there's any data points missing, and so on and so forth. So it's got both that you can download the data, and it's got nice documentation of the data, which is really great for if you want to makes it much easier to do this kind of project. Now the sort of format that I'm focusing on this lecture is comma-separated value format, or CSV format. So if you look at the raw file, I could possibly even show you actually. Let's have a quick look. If we look at final data set here, so you can see everything, there's rows for each row in the spreadsheet, and then each value in the spreadsheet is separated by a comma, presumably with some kind of complicated escape code to handle data that has commas in it. So when you actually look at the text of the text file, it's a nice simple text format, nothing binary in there. It's basically text values separated by commas for each row, and then obviously each row corresponds to a row in the spreadsheet. So it's a really easy format to process, but because of escape codes and all the rest of it, probably easier to use a Node module to extract this data rather than doing raw text processing. You can imagine doing string.split, but it's kind of fiddly, and I wouldn't bother with that, yeah, because there's perfectly good Node modules that let you extract the data. And then there are also Node modules that work with other spreadsheets, the sort of more modern Excel formats, for example. You'll find a Node module out there to be able to pull the data out of those spreadsheet formats as well, yeah. So we're going to be using TypeScript and csv-parser. That's the Node module I'm using. There's several others out there. You don't have to use csv-parser, but use one of them, I recommend, yeah. And we're going to use TypeScript, csv-parser. We're going to read football data from a Kaggle dataset, yeah? But obviously, this is just an example. If you're not into football, there's plenty, but you want to read data from a spreadsheet, then you can use this code and adapt it for your particular project, and obviously I'm there to help you in the labs with that, yeah? So just an example, let's run through this example, and you'll see it's really pretty straightforward stuff, yeah? So we're going to be reading data from spreadsheets with an English Premier League dataset from Kaggle. So this is the dataset. There's the link to it, yeah. And this is a really nice dataset. That's why I tend to use this recommend this for football projects, because you've got 20 years of matches, yeah. So if you're trying to get that kind of data from footballdata.org, whatever it's called, or the API football one, it's going to take quite a while and quite a bit of fiddling to get 20 years worth of matches for your 5 teams that you're following, yeah. And this data set's nice as well because it gives you detailed statistics about penalties, goal shots, and so on and so forth, yeah? So it's not only just giving you the results of the matches, it's got detailed in-match statistics. So if you want to do a project that was just following one team, like Arsenal, and seeing how many penalties they got in each game, you could do that very easily with this data set, yeah? So it's quite flexible, and there's a lot of data in it, which is really nice, yeah? So I kind of showed you it already on the Kaggle website. It's got the documentation there as well. And the one to focus on probably to make your life easier is just the final data set one, and which has the complete data for those 20 years of Premier League matches, yeah? So it's 1.2 megabytes, quite substantial. It's like over 6,800 rows, so it's a lot of data there, yeah? Now this example supposes that you want to follow the performance of 1 of 5 teams, but one at a time kind of thing. I'm just focusing on getting one team out of there. But one could follow the performance of 5 teams over those 20 years, yeah, and that'd be a beautiful time series data that you could do all your machine learning on as well, yeah. So if you want to follow the performance of, I'll just show you how to download one team's data, but obviously you can adapt this to download 5 teams' data, yeah. So we're going to focus on Arsenal, just an example, and we're going to read the following columns, yeah. We want to get the date of the match. This is in UK format, which I'll come back to a little later, which creates problems for us, so we need to fix. And we want to record who's the home team, who's the away team, what the full-time home goals are, and the full-time away goals are, yeah? Because sometimes Arsenal will be the home team, sometimes they'll be the away team, so we need to know whether they're playing in the match at all, and then we need to get the result, but from the Arsenal perspective, if you like, yeah? So here's the data set in Excel, right? And so these are the column titles that we want to get, the date, the home team, the away team, full-time home goals, and the full-time away goals, yeah? And then obviously this has got 6,800 rows, of that data, yeah? I'm going to use csv-parser. It's fast, simple to use. I quite like it. There's a URL, there's a website that gives you a few coding examples, and all I've done really is take their code example and just lightly adapt it to work with my particular spreadsheet, yeah? Quite a few other CSV parsers out there, as well as Node modules that can parse other spreadsheet formats. And the CSV parser requires the file system module, which you also need to install using Node, yeah, using npm install and all that, yeah. That's a CSV parser page with code examples and documentation, maximum speed, 90,000 rows per second, right? It claims to be able to do. So that's blazing fast, yeah. Obviously, it depends on your speed of your hard drive, but that's pretty good, right, for pretty much any project you're going to be doing in this coursework. So let's just talk through the code just to explain how it works. So we need to specify where the files are. Then we import the Node modules. Obviously, these will need to be installed for this to work. And then we define the structure of the data that's going to be read from each row, yeah? So each row, we want to pick out the date, home team, away team, full-time home goals, full-time away goals. If you want different information, you're going to have to change this interface, obviously. So that's what corresponds to the columns. And to read the data from the file, I'm specifying the team I want to follow, because you don't want to get all the team data for this project, right? We want either 5 teams or 1 team with detailed match statistics. I'm just keeping track of the number of entries for the team, just so we know. Now, this is the sort of how this thing works, right? We've got a read stream. So, and then that read stream is piped. As it reads each row, it'll pipe it to the CSV parser. And whenever it gets a new row, it'll call this function here with the data from that row, yeah? So this data, so this is what's called for every row in that spreadsheet, yeah? And you also, at the end, you get like it'll call an event that when the whole spreadsheet's been finished reading, yeah? So it's all kind of two callback functions, yeah? So this callback function calls this blob of code here with the data here is this kind of football data that we defined earlier. Yeah. So remember, we defined an interface football. So this data structure here, well, we can do data.date, data home team, away team, so on and so forth, to get the different bits of data. Yeah. So data.date, data away team, as I explained. Yeah. So this here lets us process the data from a single row. And we can extract the data details here. And obviously all I'm doing here is just logging out the data, yeah? But you're going to need to store it in DynamoDB and also convert it to a single number, because the football score is 2 numbers, the home team, away team, and you need to do a time series data. You need to, I know I've talked about this to you in the labs, but you can convert it to a number between 0 and 1 or 1 and 100 or something like that, where 5 is a draw, 1 is losing by more than 5 goals, 10 is winning by more than 5 goals, yeah? Talk to me in the labs if you're not clear about that. Yeah. The one thing we need to do with this data is we want to get Unix timestamps in order to link to each date rather than dates, because dates are strings, and then it's string sorting and sorting in DynamoDB isn't probably the right thing we want to do. It's much better to have the dates in a number format like Unix timestamp. Yeah. But the problem is, these dates are in UK format, whereas Unix timestamp conversion is much easier if we can get it into US format. So in UK format, we have the day, month, and year, whereas I think US format is month, day, and year. So we just need to swap the values around, which is pretty easy. Yeah. So what we do is we split the array, and then we swap the first and second entry in the date to get it into US format. Yeah. Once it's in US format, we can then do date get time. We can create a new date and then convert it to Unix using date get time. Yeah, so it's just a more useful way of storing the date. And then what you should do, which I'm not doing here, is then store it into your DynamoDB. Yeah. So let's run a little demo just to show you it's working. Give that. Okay, so I've already just run it here earlier to test, right? Let's just show you it working now. So here, so you can see with the output here, I've converted it to Unix time. If we just use the UK date, this is undefined most of the time and incorrect the other half. So we need to, as long as we converted the string date into a US format, we can then get it easily into Unix time. Remember, I'm focusing on Arsenal here. So this is Arsenal versus West Ham, Man United versus Arsenal, so on and so forth. And here we've got the goals as well. Yeah. Okay. It's working nicely, and we've got 680 rows. From this data set, which is perfect, right? Because to train a machine learning model, we can then train an individual model for each team that we're following. Yeah, so that's all working nicely, and that's it really. So the take-home message is that there's lots of data sets available online with large amounts of useful data. Yeah, web services are great. Some like the Alpha Advantage that I showed, you can just ping it once, get loads of data, dead easy. But for the football data, it's probably a more fiddly process to get all that data from an API. But obviously the disadvantage of spreadsheets is that they're just a single fixed piece of data that never changes. Great for training up a machine learning model, less good for the kind of live feed thing. So if we were building a real website around like football, for example, we would probably use maybe train the model using the historical data, but we'd definitely be pulling the live data from a web service rather than trying to get it from spreadsheets. Yeah, so just depends what you want to do, but for your projects, don't worry about the live aspect. If you want to get data from spreadsheets, that's totally fine. Yeah, the spreadsheets are often in CSV format. It might be in something else. You're also welcome to read JSON files from JSON structured data from the file. I don't really mind, but talk to me about it in the labs if you're not sure. Yeah. In this lecture, I've shown you how I can use TypeScript and a Node.js module called csv-parser to read this data. And I think, very easy to adapt this example to read data from other spreadsheets. And that's it.